Alright guys, today is Unit 8, Lesson 5, and we're going to be stretching and compressing our parabolas and doing more with completing the square. And basically what we're going to be doing is just working with quadratics where the leading coefficient is greater than 1. So something like when we had you do, let's see if I can, there we go, 2x squared plus 3x minus 11. And those were harder to factor if you remember. And just like that, it's going to be harder to do the completing the squares. So we have to do some additional practice with that. So first we're going to do some easy stuff here. Let's get rid of this. Oh, I'm supposed to get rid of it. There we go. So let's understand what A really does when we have a leading coefficient A that's not 1. So maybe 2 or 4 or something. And so here we go. We know if A is positive, it opens upward because it's a happy parabola. And if it's negative, it opens downward because it's sad. Just remember, positive is happy, yay, and negative is sad. And I don't know why it's doing that. Okay, that looks terrible. You know what I mean. Oh, man. There we go. All right, so what we want you to do is, using your calculator, just sketch the best you can using these different graphs. So y equals x squared, y equals 2x squared, and y equals 4x squared. Make sure you label them, and if you have colored pencils or pens around, you should do these in different color. It will help you see them better. So do those three right on this graph down here. So hit pause and do that now, please. Okay, so hopefully you got something looking like this. And I think I did that. Yes, perfect. So the y equals x squared is this red one. And then the y equals 2x squared is the blue one. And y equals 4x squared is this purple one. And so what do we notice happening? Well, it looks like they're basically, everything staying put as a turning point, but they're getting thinner. This red one is the widest one. The blue one got a little thinner, and the purple one's the thinnest. And you see the pattern that the 2 is bigger than this 1, so here's the 2, and the 4 is the biggest number we're multiplying, and it even got thinner. And I wish we would have done one like this. If I gave you one like y equals 1/2 x squared, well, where do you think that's going to go? 1/2 x squared is the smallest one, and the smallest one's on the outside, so that would be somewhere out here. I don't know what is up with this. It's a different laptop. I dropped my other one. It's broke now, so I have to use this bad one. Alright, and that would be this one here. So y equals 1/2 x squared. And hopefully you notice the pattern is that when we're multiplying something by a leading coefficient greater than 1, it makes it thinner or wider. And it is based on the value. The bigger the number, the wider it's going to be. The smaller a number, it's going to get kind of compressed, and I'll show you that right over here. Hopefully. There we go. So here's what we want to say. The A coefficient makes the parabola thinner or wider. Okay, it's not going to move it up or down or anywhere. It's just going to make it thinner or wider. If the A is greater than 1, then the graph will stretch what we call vertically and get thinner. So I want you to think of a basketball. If you were to grab it and stretch it up vertically, wouldn't the basketball get thinner? Because it's still the same material, but you're stretching it up. And if A is greater than 0 but less than 1, so it can't be negative, then the graph will compress vertically and get wider. So again, think of the basketball. If you were to put your hand on it and squish it and compress it down, then it would get wider on the side. And if you think about that, it makes sense. If we think of input and output values right here, if I put 1 in there, I'd get 1 squared, which is 1. So I'd get this 1, 1. If I put 1 in here, I'm going to get 1 squared times 2. I'm going to get 1, 2. And if I put 1 in here, I'm going to get 1 squared, which is 1 times 4. I'm going to get 1, 4. So you can see what's happening. For the same input value, I'm actually going higher on the graph. So that's why it's getting closer to the y-axis. So our first one was kind of lower, and if I graph that, it'd be kind of wide. Our second one's a little higher, and so on. So that's why these are getting thinner, because we're raising the input value, the output value is going up more. Alright, so hopefully that kind of makes sense there, and we have to get this down because they are going to call this stretch vertically. They're not going to say thinner, and they're going to call it compressed vertically. So think of a basketball. If you stretch it up vertically, it gets thinner. If you compress it vertically, it gets wider. And I think it's discussed down here too. So you can kind of read this over. It's pretty much what I was talking about. Alright, so that, now hopefully this will be easy for you. So I want you to do all of these. So just read the directions here, hit pause, and answer these on your own. So do that now, please. Alright, let's see how you did with these. So first, what I'm going to do is look for that, okay, here's a negative 1, and here's a negative 1. So those I know are down here on the bottom. And remember, the bigger this number is, the thinner it gets. So therefore, this must be the widest one, and this must be the thinnest one. So I know that this one here must be the negative x squared. So that would be the 3 down there. And therefore, this must be the oh, not 3, I apologize. That's 5. Just got that wrong. This one would be 5. And therefore, this one has to be the negative 2x squared, and that's the 3. So that takes care of those. Now I have the positive ones left. And remember that this is the smallest number. Let's use a different color. And then this one is in the middle. And then this one right here is the largest. So that must be the thinnest one. Because remember, it's kind of opposite, because we're taking that point and we're stretching it up. Okay? So that's why it's going to get thinner. So that would be this one here. So that must be number 1. And then the green one is in the middle, and that's just your parent function. So there's that one, and that must be number 4. And this one, we squished it down. We made it half. So here's the point. Think of squishing it down. So again, that basketball is going to get wide when you squish it down. And if you take the basketball and stretch it, it's going to get thinner. And hopefully that makes sense. And so therefore, this blue one out here should be number 2. All right. Hopefully that went okay for you. And now it's time to do some completing the square. And this is not easy. I don't want to say it's not easy. It's just a little more than last time, so let's pay attention to it. And this form here is what they call it in completing the square form or vertex form. Okay, so you need to have, there's your different values. So this is just completing the square form. So when you notice this one, it's different because we have a leading coefficient of 2. So we can't start right away by just taking half our b. The first step you need to do is do the GCF, and I don't want to say GCF, we're just going to factor out the greatest common number, not the x's, of the a and b term. So hopefully you can see that I could factor a 2 out of those. I want to leave the x's though. So that's our first thing, and what I want you to do is use a bracket for this, and I'll show you why. I will make things a little easier. So I just divided this by 2 and this by 2, and then I'm only going to do the a and b term, and then the c term is going to stay the same like that. Because remember, we're trying to turn the a and b term into a perfect square trinomial. That's what we're trying to do. Now from here, let's ignore the 2 for right now and just look at this and do what we've normally done. We take the b term, divide it by 2, and then square it and get 9. And we know that's what we're going to add and subtract in here to make this a perfect square trinomial. So that's what you're going to do. This is the same completing square. Now notice I added a parentheses here. Okay, and there's my minus. And then remember, I'm going to add 9, and that makes my perfect square trinomial. But remember, I have to also subtract the 9. And that's all in these brackets here. And this is important, I'll show you. So we're adding the plus 9 minus 9 in right there. Okay? And then we still have the plus 11. All right? Now, you guys should know that we could take this perfect square trinomial, and we could actually break that down into something like that. You should know that this here breaks down to that. That's all I did. So everything else stays the same. We got the 2 there, and we still have this minus 9 in the brackets there and the plus 11. Now what you're going to do is that this 2 has to be distributed here and to this minus 9. That's why I'm using the brackets, to remember that this leading coefficient is being multiplied by this thing, which turned into all of this, which finally turned into all of this. So now we have to distribute, not to the 11 out there. So that's what we're doing next. Okay, so I just distribute the 2. Now I'm not going to distribute into here because the squared have to be dealt with before I can multiply. So you can't do 2 times x and 2 times 3 because of that squared. So we're just going to write it like this. 2 times this. Then I have to do 2 times that. And now I could get rid of the brackets and just write the plus 11. Alright, now I'm going to simplify this in my head because that's negative 18 there plus 11, and that would make negative 7. Alright, and now it's in vertex form, and that was not easy. Hopefully you followed it, so I'll help you do another one. But let's look at question B first. Now it says what are the turning point, and use some type of table just to form. So you could put it in your calculator. You could put this equation or the original equation in. But what's the turning point, and then use a table to support your answer. So hit pause and try that now, please. Alright, hopefully you said the turning point was 3, negative 7. And here was the table you could have put in your calculator. Remember, this is the opposite. So this is really moving to the right. So positive 3 and down 7. And this is the table you could generate. And you can see that that's that vertex point right in the middle. Not a big deal there. Okay, now I'm going to show you one more of these, and then I want you to try the 3 on your own. So I don't need to read through all that. It's basically saying put it in vertex form, and then we have to identify the turning point and then state if it's a maximum or minimum. So a lot of stuff going on. So let me go through A, and then I want you to do the rest on your own. So remember, the first thing you're going to do is going to factor out the GCF, but again, it's just the number, not the letters, because we need this to be a trinomial. Alright, so I took the 5 out, and now we're going to do our regular thing where I divide that by 2, which would be 2, and square it. So that means I have to add 4 and subtract 4 in the brackets there. So I'm adding 4 and subtracting 4 in the brackets. But notice I also used my parentheses to identify that trinomial. So again, there's this, and then I added 4, subtracted 4, turned this into the trinomial. Now we know we could take this into the perfect square binomial. So again, I turn this into that there. You should know how to do that now. And then there's the minus 4 there, and the plus 23. Then remember, I'm going to take the 5 and distribute it here and here. And remember, you can't distribute it in here because this is squared. So you're just going to distribute it right there, and distribute it to the 4, and then we have the plus 23. And then now I'm going to simplify this. I know this is negative 20 plus 3, so that would be plus 3. So now it's in vertex form. And now I can take the vertex. We know this would be a minus 2 plus 3. And remember, this is positive, so it's a happy parabola. So therefore, this point must be at the top of it, and therefore must be a maximum. Alright, I said that wrong because I said this is a happy parabola. That's better. That's happy. And now it's at the bottom, so that's a minimum. There we go. Sorry about that. Alright, so I want you to do the rest of the 3 on your own. They are not easy. If you want to try one and hit play and then try another one, but you really should attempt this on your own. So hit pause and try those now. Alright, so I'm running out of time, so I'm just going to show you a lot of answers, and you need to see how you did. Now this one was a negative 2, so make sure you factor a negative 2 out. And when you do negative 2, this would have to be negative 2 there. If you made this positive 2, you probably got it wrong, because negative 2 times negative 2 would be that positive 4, so be careful. The rest of it's just like I said. Now I'm going to make my plus 1 minus 1 because I divided that by 2 and squared it. Okay. So I'm not going to explain all these. You'll have to follow it, and if you're really struggling with this in class, then come see one of us and we'll help you out. And there's your turning point, and there's your maximum, because it is a sad parabola, so therefore this would be on the top. And remember, this does not affect your turning point. Alright, so now I have to reveal these kind of fast. Make sure you have enough time. There we go. And there you go. Again, you really hopefully tried it on your own. Follow, see what I did. Take each step one at a time, and if this is super confusing, get some extra help tomorrow. Alright, we'll see you in class.